All right, let's dive in. Today, we are talking about one of the most powerful tools you have for building high-performance systems, caching. It's kind of the secret sauce that makes everything feel snappy and lightning fast. So let's pull back the curtain and look at the strategies that make it all work.
I mean, we've all been there, haven't we? Just staring at that little loading spinner, waiting and waiting for a page to pop up. It's so frustrating. That delay, what we tech folks call latency, that's the exact problem caching is built to destroy. It's all about making the distance between the user and their data practically zero, so everything feels instantaneous.
So what is caching at its heart? It's actually a pretty simple idea. You just create this small, super fast storage area that holds copies of the data people ask for the most. By grabbing data from this speedy little spot, you don't have to make that long, slow, and expensive trip all the way back to the main database every single time. To really make this click, let's use an analogy pretty much everyone gets: a busy coffee shop. Okay, so the database, that's the giant storage room in the back. It has everything, but it takes time to go find stuff. The cache? Well, that's the barista's counter. They've got the milk, the most popular syrups, the coffee beans, all right there within arm's reach. Grabbing milk from the counter is instant. A trip to the back room, not so much. That is caching in a nutshell. So what's the game plan for today? First, we're going to ask, where can you even stick a cache in your system? Then we'll get into the really tricky part. How do you keep that cache and your database from telling two different stories? After that, we'll compare the different ways to do it, figure out what to do when your cache is full to the brim, and then we'll wrap up with the absolute must-know stuff for every developer out there. Okay, let's start this journey by literally following a user's request as it makes its way through a system. You'll see that at almost every stop along the way, there's a chance to use a cache and speed things up, starting right from the user's own computer. So the very first level, the one closest to home, is the user's web browser itself. When you visit a website, your browser is smart enough to save things that don't change much, like logos, images, and those big CSS-style files. The analogy here is perfect. It's like keeping your most used textbook right on your desk, instead of having to run to the library every single time you need to look something up. The next time you visit that site, boom, it loads in a flash because all that stuff is already there. Taking one step out from the browser, we hit the CDN, which stands for Content Delivery Network. You've probably heard of services like Cloudflare or Amazon CloudFront. What they do is they have this huge global network of servers, and they store copies of your website's content on them. This is just like a coffee shop franchise, right? If you live in London, you don't order your coffee from the main headquarters in Seattle. You just go to the local shop around the corner. A CDN does exactly that, serving your website from a server that's physically close to the user, which dramatically cuts down that load time. Okay, now we're getting inside our own infrastructure. An application server cache is an in-memory cache, meaning it lives in the super-fast RAM, running on the very same machine as our application code. Think of a chef keeping their salt, pepper, and olive oil right there on the countertop. Access is unbelievably fast because there's no network trip involved. But here's the catch. If you have a bunch of servers, each one has its own little private cache, and that can lead to some real headaches with data being inconsistent between them. So to fix that inconsistency problem, we bring in the big guns, a global distributed cache. This is where tools like Redis or Memcached come into play. It's a completely separate service that all of your application servers talk to. It's like a central library for the entire campus. Everyone goes to the same place to check out a book, so everyone is working with the same information. This gives you a shared, consistent source of cache data. Sure, it's a tiny bit slower than the local cache because you have to make a network call, but it's built to scale and it solves that data sync problem beautifully. Okay, so we figured out where we can put our cache. But now we get to the really hard part. How do we manage the data in there? How do we make sure the data in our super fast cache doesn't get old and out of sync with our database, which is our ultimate source of truth? This is where cache write policies come in, and they are absolutely crucial. Let's start with the one you're going to see most often in the wild, cache aside. With this pattern, your application code is the boss. First, it checks the cache. Is the data there? Great, that's a cache hit. We just return it and we're done. But if it's not there, what we call a cache miss, then the application itself has to do the work. It goes to the database, gets the data, puts a copy into the cache for the next time, and then returns it to the user. We call this lazy loading because we only bother putting data into the cache when it's actually asked for. Now, what if you need absolute ironclad consistency? For that, we have the write-through strategy. When your app needs to write new data, it writes it to the cache and the database at the same time. And here's the key part.
The whole operation isn't considered a success until both writes have been confirmed. This guarantees your cache will never be out of date. The trade-off? Well, every single write is now slower because you're always doing two things instead of just one.
On the total opposite end of the spectrum is write back, and this one is all about speed. Here, your application writes data only to the cache. The cache immediately says, got it, and your application can move on to the next thing. Then, in the background, the cache takes on the job of eventually writing that data to the database. This is amazing for systems with a ton of writes, because it feels incredibly fast. But, and this is a really big but, what happens if the cache server crashes before it had a chance to save that data to the database? Poof, you could lose data. This adds a lot of complexity to your system. You really need solid ways to handle failures. It's the ultimate trade-off, speed versus safety. Now, just to round things out, there are a few other policies worth knowing. Read-through is a neat one where the cache itself knows how to talk to the database. This can really clean up your application code. Then you've got write-around, where writes skip the cache entirely and go straight to the database. This is useful when you're logging huge amounts of data you probably won't need to read again anytime soon. And finally, there's refresh ahead, which is really clever. It tries to predict which data is about to expire and refreshes it ahead of time so a user never has to experience that first slow load. So that's a whole lot of options. How in the world do you choose the right one? Well, it all comes down to a balancing act. You have to look at the specific needs of your application and weigh the trade-offs between speed, how fresh the data needs to be, and just how complicated the solution is to build and maintain. Let's just break it down with this table, you see? Cache aside is easy to implement and has low write latency, but your data might be a little stale sometimes. It's perfect for things like user profiles on a social media site. Then you have write through. The data is always fresh, but your writes are slower. This is what you'd want for something like a banking transaction system, where consistency is everything. And finally, write back gives you that super low write latency, but it's complex and you risk stale data. You might feed this in a high-frequency trading system. The big takeaway here is that there's no single best strategy. It always depends on your use case. Right, one more thing. Your cache isn't a bottomless pit. It's a small, limited, and very valuable piece of real estate. Sooner or later, it's going to fill up. When you need to add a new piece of data, you have to kick something else out to make room. The question is, how do you decide who gets the boot? This is where eviction policies come into the picture. Probably the most famous one is LRU, or least recently used. The logic is simple. If you haven't used an item in a while, you probably don't need it anymore, so out it goes. Then there's LFU, or least frequently used, which kicks out the item that has been accessed the fewest times, thinking it's less important. And FIFO, or first in, first out, is the simplest. It just kicks out the oldest item, no matter how popular it is. Each one has its pros and cons, but honestly, LRU is the one you'll see and talk about most of the time. Okay, let's wrap this all up. If you're designing systems, or maybe you're getting ready for a big technical interview, these are the concepts that you absolutely have to have locked down cold. So here's your final cheat sheet. First, know the different levels where you can cache, all the way from the browser to a global service like Redis. Second, you have to be able to explain the big three write policies: cache aside, write through, and write back, and all their trade-offs. Third, understand what an eviction policy is and why LRU is such a popular choice. And finally, whenever you're thinking about a system that needs to scale, you should immediately be thinking about distributed caches like Redis or Memcached. And remember this, knowing this stuff is one thing, but being able to explain it is another. When you're in a system design interview or just brainstorming with your team, using a simple analogy, like our coffee shop, can be the absolute best way to make your point clearly. It shows you don't just know the definitions, you really get the why behind them. And I'll leave you with this one final thought to chew on. Caching will make your system feel incredibly fast, but that speed almost always comes with a price tag: complexity and the risk of data inconsistency. The real challenge for any engineer isn't just to add a cache, it's to choose the right strategies that strike that perfect balance for what you're trying to build. Thanks for tuning in.